Let's work a limited reactant problem. This is number 1 from today's homework. First step, you got to make sure your equation is balanced. This one is not because I got the same number of sulfurs on each side, but different numbers of O's. So let's balance those oxygens. I've got 2 here, 3 here. They are a common factor of 6. So let's try to get 6 oxygens on each side. I can do that by multiplying my 3 oxygens by 2, my 2 oxygens by 3. Now we got 6 oxygens on each side. That unbalanced our sulfurs though. 2 here, 1 here. All right, fixed. Everything is balanced now. First part is to convert your grams of each of your reactants into moles. That's what you always got to do when you're doing a limited reactant problem. The ratios in your equation only work with moles. They don't work with grams. So let's get these into moles. Here is our moles to mass conversion formula. Moles equals mass over formula mass. So for our sulfur, moles will equal our mass. Our given is 128.3 divided by formula mass of sulfur, 32.07. And do your division, that will come up to 4 moles of sulfur. And notice how I did not use this coefficient in the balanced equation at all. That has nothing to do with converting your given mass of sulfur into your given moles of sulfur. And let's do oxygen real quick. Again, moles of oxygen is going to equal the mass of your oxygen, 160, divided by formula mass of your O2, which is going to be 32. And do your division here, and that will give you 5 moles of oxygen gas, 5 moles of O2. And again, you're only looking at the atoms that make up your molecule when you're doing this mole conversion. It has nothing to do with the coefficients in your balanced chemical equation. All right, so this is a balanced equation. We got our moles of each one. Let's find out which one is limited. To do that, you use this little formula for comparing amounts of substances in your balanced equation. Moles of your given. This is an actual quantity times the ratio of their coefficients in your balanced chemical equation. The top one is what you're looking for to compare it to. The bottom is the given, the molecule that you did right here. When you're looking for which one of your reactants is limiting, you compare your given amounts of one to the other. Let's compare the given amount of sulfur to oxygen, and that can tell us which one will run out first when we react them. I'm going to use this formula. I'm going to compare sulfur to oxygen, so I'll put my quantity of sulfur in this position. My actual quantity of sulfur is 4.00 moles, 4.00 moles of sulfur. Now we multiply it by the ratio of the one we are comparing it to, oxygen, to the one we are comparing, sulfur. And in your ratio, it is just your coefficients from your balanced equation. The coefficient for O2 is 3. Coefficient for sulfur is 2. Moles sulfur cancel, and that will give us 4 times 3, 12 moles oxygen over 2, which will give us 6 moles of O2. And what does this tell us? This tells us that if we wanted to use up all 4.0 moles of the sulfur that we are starting with here, we would need 6.00 moles of oxygen gas. I'll say it again. If we wanted to use up all 4 moles of our sulfur, we would need 6 moles of O2. Well, how much O2 do we have? Well, we figured out we only have 5 moles of O2. If we wanted to use up all this sulfur, we would need 6 moles of O2, but we've only got 5. That means that the reaction is going to stop when the oxygen runs out. We are not going to have enough oxygen to use up all this sulfur. We've only got 5 moles, we need 6. And that tells us that the O2 limits, because we don't have on hand as much as we would need to use up all of our sulfur. Let's see how that would work the other way around. What if you compared your oxygen to your sulfur instead of sulfur to oxygen? That works too. Let's try it. So let's take our given amount of oxygen, we'll put it in this position in our formula. 5 moles of oxygen. Now we do it times the ratio of what we are comparing it to, which is sulfur. Let's take take those coefficients from the equation. Sulfur is 2, oxygen is 3. Moles of oxygen cancels. 5 times 2 is 10, divided by 3. And that is going to be, made it hard for myself, 3.333, whoops, 3.333 moles of sulfur. All right, what this has told us that if we wanted to use up all 5 of our moles of oxygen that we're starting with, we would need 3 1/3 moles of sulfur. How much sulfur do we have? We got more than that. We got 4. So by the time that we have used up all of our oxygen, all of our 5 moles, we will have used up only 3.3 moles of our sulfur. That means that the oxygen is going to run out first, because when we've used it all, we'll still have some sulfur left over because we started with 4, only need 3.3. Again, this is going to show you that the oxygen is going to run out first, and you get the same answer. The oxygen limits. Next part, how much of your excess is going to remain? Since we know that oxygen is limiting, means our sulfur is the one that's in excess. All right, first we got to figure out how much of our excess we are going to use. And how we do that is we use the same formula. We put the limiting reactant right here and compare it to the other reactant. This is math we've done already, but we'll do it anyway. So again, when you're trying to figure out how much of your excess you are using, you put the limited one in this position. We figured out our limited one is our oxygen, 5 moles of O2, times that ratio, the one you're comparing to the one you are comparing it to, so sulfur. Get those coefficients from your balanced chemical equation. You can tell this is the math we just did. That's okay. Why did I write a 0? This is a 3. It's this 3 right here. 5 times 2 is going to be, I'll put it down here, 10 moles of sulfur over 3. And again, we're going to get that 3.333 moles sulfur. This is telling us that when we've used up all of our limited reactant, we will be using up 3.33 moles of our excess sulfur. We started with 4 moles of sulfur. When we have run out of our limited reactant, we'll have used 3.333 moles of our sulfur. Do our subtraction, and that will get us to 1.667 moles sulfur remain. When our reaction stops, and it stops because we run out of our limited reactant, our oxygen gas, we will be left with 1.667 moles of sulfur just sitting around that can't react. Let's figure out how we can learn how much SO3 we form. Our SO3. So again, to figure out how much SO3 we're going to form when this reaction stops, when we run out of limited reactant, again, we use this formula. When you want to figure out how much of any product you make, you put the limited reactant in this position right here. Our limited reactant is our O2. We figured out we start with 5 moles of O2. Put that right here, 5.00 moles of O2. Set up your ratio, the one that you're given on the bottom, the one you're comparing it to on the top, which is the SO3. We want to find out how much SO3 will make. Get your coefficients. Coefficient for O2 is 3. Coefficient for SO3 is 2. And again, we got 10 moles of SO3. Ignore that. Over 3. And again, that's going to come down to 3.333 moles of SO3. We're going to form 3.333 moles of SO3 when our limited reactant runs out and the reaction stops. The question, though, is asking for grams. So we have to convert our moles of SO3 to grams. We'll use this formula right here. We have moles of SO3, 3.333 times formula mass of SO3. I calculated it already. It is 80.07. And again, that is just sulfur, the atomic mass of sulfur, plus the atomic mass of 3 oxygens to get this formula mass. It has nothing to do with the coefficients in your equation. It is just the sum of all the atoms in your compound here. And do our math here, multiply each side by 80.07. And that will tell us that our mass of the SO3 that we're forming is 266.9 grams of SO3. That'll be your answer for the last part. I hope that's clear. Have a great day.